And so again, if it's ever unsure, like where am I getting that times 5.5? I've just taken the same units of measurements. I've taken the flour. If I want to know how many times 2 fits into 11, I can just do 11 divided by 2, and that's where I got that 5.5. 11 divided by 5.5 gives me 2. 2 times 5.5 gives me 11. So you can always like test it out. So that's what ratios is. But the main part of this unit realistically was, though, it was slopes, right? We were looking at slopes. That's what the most big part of this unit is. And so specifically, a slope shows how steep something is slanted, how steep a line is. And we got a couple of different formulas for this. The core concept, however, is this. I'll write down like all the formulas, but the core concept is really this. M stands for slope, right? Whenever we say slope in math, we're lazy. We just use the word M. Technically, it's the, it's the change in vertical distance divided by the change in horizontal distance. And this kind of works its way into a couple of different formulas, right? But this is what it is at its key concepts. Like one of those formulas we know was, let me just erase that. Yeah, M equals rise divided by run. How high up does something go? And how far across does it go? We've also seen it used in a couple places where, well, what if we do, come on, where it's y2 minus y1 all divided by x2 minus x1, right? That's if you have 2 points on a graph, you're trying to figure out the slope of them. But that's still all the same stuff, right? It's how it's changing vertically and how it's changing horizontally. It's how does the rise change? How does the run change? Those are all the three same things. And so just like before, if I take those ratios or that fraction up top, and if I change the flour and water to rise over run, you can still solve it the exact same way, right? It's solved the exact same way. All I've done is I've just changed the flour and water to rise over run. But you can still set up the exact same question to work out. Come on, computer. So we've seen stuff like that. Now, in this unit, we also got an introduction into Pythagoras and the tangent ratio. I'm not going to do a full review of those. That'll happen later. We'll just do those in their own specific sections. And so if you're unsure about that as you go through the review, that's fine. You can always come back to that on Wednesday, I think, which is totally fine. I want to more so focus just on slopes right now. So we were also introduced to a couple things. One was grade, if you remember. This specifically is the slope of a road or a surface. And it's usually expressed as a percentage. So if I say that, hey, there's a 6% grade in a road, what that means is it rises I'm going to say meters, any unit of measurement, meters, feet, yards, miles, centimeters. It's all the same thing. It's going to rise 6 meters for every 100 meters far it is. Oops. And so we have a special formula for this. I'm going to write it in blue here. So the percent grade is equal to the rise over run times 100. So I'm just using the blue here to kind of show this. The rise over run times 100, right? It's turning the decimal into a percentage is really what that is. A second, get caught up. Okay. So that's what our grade is. We were also introduced to a concept of that red. We're also introduced to a concept of pitch, which is basically in most cases we look at like something like the slope of a roof. And basically what we do is we express this, we show this, we write this down as, as the number of inches of rise for every 12 inches of run. I'm just going to move this down here, actually. Actually, no, I'm not. Okay. So I'll make you a little picture here to kind of help out with that. So if I have a roof that's like this, well, I can see that it rises 6 inches for every 12 that it runs across, which would mean that the pitch in this case would be 6 to 12. And you can see it's expressed as a ratio. You could do it as a fraction if you're trying to solve a problem with it as well. But that's what it would be here. It'd be a 6 over 12. So it's a way to show, again, how steep something is. We don't use the percent grades, however, for roofs. That's mostly reserved for roads. But grade and pitch are technically the same thing. It's how high up does it rise for every little bit that it runs. So, oh, hello. And then, sorry, everyone have that?
I do, yeah.
Anyone not have that? Okay. So the last little thing that we kind of looked with, we've already talked about this thing here, this y2 minus y1 over x2 minus x1. This thing right here is when we have 2 points on a graph, right? So I'm going to really quickly rewrite that. You don't have to if you don't want to, but that m equals y2 minus y1 all over x2 minus x1. So this thing right here it's used to calculate the slope of a line with 2 points on a graph. So for example, and you don't need to draw this accurately, I'm just drawing a sample graph here. If I give you a sample chart here, and if I give you let's say this is 1, 2, 3, 4, and 5. I'm just kind of winging it, right? It doesn't need to look accurate. It shows the point of what we're trying to make. I'm gonna make my points really, really big and pronounced for this. So if I give you a graph like this, and this is a nice straight line. If I'm giving you something like this and I say, hey, find the slope of this, what do you have to do? You have to find 2 of these points to be able to do that, right? And you can pick any 2 points. There's 3 on here. It does not matter which 2 you use. But how do we read a graph again?
Right.
Left to right. Read it like a book. I need to read this left to right. That's where these 2s and these 1s comes in. So first off, I'm going to find 2 points on here. This first one here, the coordinates of this one are
1, 0.
the x is going to be 0 and the y is going to be 1, because we always go x and then y, right? So in this case, it is 0 and 1. Yeah, I'm recording it right now, so you'll be able to kind of get the review that way. We're also doing a concept check for unit 6 today. So I've picked 1 point here. That's this one, just to kind of show it. And now I'm going to pick any other point. I'm just going to pick this one here, just for the sake of room. I can see that the x of this one's going to be 5 and the y is going to be 3. So this one's just 5 and then 3. It's always x and then y, x and then y. Now, my question for you is, okay, I have 2 y's and I have 2 x's, but which one's the first, which one's the second? Well, as you read it from left to right, that's how you figure out which one's your first and which one's your second. So if I'm reading this point right here, I can see that these are my 1s right here. And then these would be my 2s. So now all of a sudden I have a y2, a y1, an x2, and an x1. All I now need to do is just substitute that stuff in. So now my slope of this is y2, which is the 3, subtract y1, which is the 1, all divided by x2, which is the 5, subtract x1, which is the 0. And all of a sudden, my slope here I'm going to see is going to be 2 over 5, right? Or yes. So I think this is the, oh no, there's 2 more here. The other one, of course, is when we read a graph. If I give you a graph here and I say, hey, here's a random point. We've seen this a lot. I want you to draw a line with a slope of, I don't know, let's say negative like 1 over 2, just as an example there. Well, if it's negative, as you read it from left to right, does the line go up or down? Down. Yeah, a negative slope means as you read from left to right, the line goes down. This one up here, this is a positive slope, right? Because as you go from left to right, it's going up. So what this is saying is, hey, I want you to draw a line. I want you to draw a line, draw a point that's going to have a slope of, it goes down 1 for every 2 it goes across. So I would just go down 1 and I would go 2 across. And all of a sudden now I would have a line that I could make that goes through that. Okay. So we're just gonna actually cut the review off there. Like I said, it's just going over like the really like the basic stuff. Now you always have like your actual notes that you've done that you're able to, because right, we just had 3 topics. Yeah. So you always have your notes that you're able to use for this. But so I handed you out that review there. Where is it?
This is
Review.
unit 3.
It starts at unit free. You will have to actually skip forward a couple pages. That was a print in error. Where did I put the review on here?
Last page. Or second last page.
Oh yeah, okay, yeah. I'm just on my files. Where did I put the? Oh, is this it? Here we go. So you have your review here, right? So what you guys are able to do is I recommend you do is go through it to unit 1, so second last page there, and then just try and answer this stuff here. Use your notes you just took, use your actual big booklet of notes to try and answer it. And if you get stuck, ask for help. Like this is the last time you're realistically going to be able to engage with this stuff. And if you didn't do well in a concept check on it before, this is a good chance to relearn that material, do better on that concept check, perhaps, so that your mark improves. So this is just our last time to be able to do it. So the rest of the class is really going to be dedicated to, hey, you have some time to finish up this unit. After the break, we will do a concept check for unit 6. But the rest of the class is really just dedicated to unit 1. So, and if you somehow finish this stuff, the workbook's online. You can look at that. You can try out some of those questions again. Maybe you have some leftover stuff in your actual booklet. You could look at your booklet and just write the question down on paper. We have the textbooks down back. So it's just, there's lots of times to be able to practice this stuff. And if you're not sure on how to do something, you can ask for help on it, of course, as well. So yeah.